Good day once again. Today we are looking at the subject mathematics, and the topic we shall be considering today is volume. Volume is a broad topic that cuts across the basic 5, 6, GSS 1 to 3, even SS class in mathematics. But for the scope of our study today, we are taking into consideration the volume of prisms. Volume of prisms. And this is limited to basic 5, basic 6, GSS 1, 2, and even GSS 3. Volume of prisms. That is what we are considering today. I believe we shall have a very nice time together as we navigate through this wonderful topic, volume of prisms. I remain your tutor, Alabi Oluwadamilare. Now, to start with, what is volume? What is volume? Volume is a three-dimensional measure of space. A three-dimensional measure of space. That is, the amount of space occupied by a solid shape. Now, that means when we talk about volume, we are talking about solid shapes. Solid shapes, because the 3D shapes, that is the three-dimensional shapes, are referred to as solid shapes. So when we talk about volume, we are not talking about plane shapes, but basically solid shapes. Now, a quick look at what solid shapes are before we go deeply into our topic for today. What are solid shapes? Solid shapes, like I said earlier on, are three-dimensional shapes, 3D shapes. And what do we mean by three-dimensional? The three dimensions are length, the breadth, which can also be regarded as width, and height, that can also be called the depth. These three parts make up a solid shape. A solid shape without these three major parts, a shape without these three major parts may not be regarded as a solid shape. So a quick look at some common examples of solid shapes. We have so many of them. We have the cube, which is a very common one. We have cuboid. We have cone, cylinders, triangular prism, pyramids, different types of pyramids. It could be rectangular pyramid, square pyramid, cone, and so on. But because of the scope of our study, we are going to focus more on prisms. Focus more on prisms. Now, these are some of the shapes that we can come across. Cylinder, we can see how it looks like. The triangular prism, some of the common prisms that we have. We have the cuboid, which is the rectangular prism. We have hexagonal prism. We have cube, which is as well called square prism. So now let's quickly take a look at the types of solid shapes before we move further. From the examples of solid shapes listed above, there are two basic types of solid shapes. Solid shapes are divided into two categories. These are prisms and pyramid. Prisms and pyramid. If we have a good understanding of these two categories, then there is no question that comes under solid shapes that will not be able to attempt. Prisms and pyramid are the two types of solid shape. Now, quickly, we take a look at what prisms are. So we are going to be focusing on prism for now. Prisms. Prisms are solid shapes with uniform cross sections. That is, the face and the bottom have same plane shapes. Now, what does this mean? For a clearer understanding, a prism is a shape that has a uniform cross section. What do we mean by uniform cross section? That is, when you pick up any prism and you slice it uniformly across it, the shape you have will be the same shape when you slice it at another point. For example, your onions. When you pick a bulb of onions, you slice the bulb of onions at any point, you have a circular shape. That shows is an example of a prism. So a prism is a solid shape with uniform cross section. Or if you don't want to use the word cross section, you can as well say it is a solid shape that has same plane shape at the bottom and at the top. So when you look at the top and the bottom of the prism, the plane shape, you have a plane shape at the bottom, plane shape at the top. Now this implies that all prisms are made of a plane shape. Yes, of course. For example, if you take a look at the solid shape shown earlier on, cylinder. A cylinder has a circular top and a circular bottom. So as a result, we can call a cylinder a circular prism. A circular prism. And if you slice cylinder around the curved edge, you get a circular face. So that is a circular prism. Good. If you look at a cylinder again, you will discover that it is a shape made by piling up plane shape called circle. If you take a circle, put it down, put another circle on it, put another circle on it, put another circle on it. The pile you have forms a solid shape called a cylinder. So that is why a cylinder can as well be called a circular prism. Now, look at triangular prism, the next solid shape there. If you slice through, the shape you get is a triangle. And if you look at the top and the bottom, you will discover that the two shapes you have there are triangles. They are triangles. So a triangular prism is formed by piling up triangle. So we can say triangular prism is a pile of triangle. A pile of triangle gives a triangular prism. And looking at cuboid there, cuboid. If you look at the top of that shape, what does it look like? Okay, the same thing you have on your mind. It is a rectangle. It is a rectangle. So that implies that the rectangular prism can be formed, that is cuboid can be formed by piling up rectangles. Cuboid can be formed by piling up rectangles. So cuboid is a pile of rectangle. And that is why we can as well call it a rectangular prism. The face, the top is rectangle, the bottom is rectangle. Now looking at the next shape there, that is not a very common shape, but it is also a prism. Remember, for a solid shape to be a prism, the condition is that the top face and the bottom face must be the same type of plane shape. Now, if you look at the next shape, the top is a hexagon. The top is a hexagon. Although we can't see the bottom clearly because it's lying on the bottom. So the bottom, if it is turned over, is also a hexagon. So if you now put the pile of hexagons together, what you have there is hexagonal prism. Hexagonal prism. And the last one, which is a very popular one, cube. Cube is a pile of square. If you look at the top and the bottom, it is formed by squares. So that is a square prism. A square prism. So let's quickly go back to the common prisms we have. Like I've explained, prisms and their cross section. Cube, the cross section of it. Remember I said earlier on that the cross section of the shape is the plane shape that makes up the shape. So a cube is made up by squares. So the cross section is square. Cuboid is made up by rectangle. The cross section is a rectangle. Cylinder, cross section is circle. Triangular prism, cross section is triangle. On and on and on like that. I believe with this now you have a clearer understanding of what prisms are. So when you see even prisms in nature, real life objects that are prisms, you should be able to identify them. Quickly, let's touch this aspect before we close for today, and that is looking at the formula for calculating volume of prism. Remember, that is what we want to talk about, volume of prisms. Now, what is the formula for calculating the volume of prisms? Now, there is a general formula. What I don't encourage students to do is to cram. By the time you cram, you have so many things you have crammed, and sometimes you may forget. But when you know the origin of the formula, it is easier for you to reproduce the formula at any time. Now, what is the formula for calculating the volume of prism? Generally, it is given as the area of cross-section times height or length. Remember, your length can also be used as your height. Okay, they are both distances. So, can you say it with me? Formula for calculating volume of prism is given as what? Area of cross-section times height. Remember, the cross-section also means the face. So that is area of face times the height or the length. So can we just pick a cylinder as a very good example for today's lesson? Cylinder. Remember, we looked at cylinder the other time. A cylinder has a circular face. And we said the volume of a prism is the area of the face, which is the cross-section, times height. So let's now take a look at the formula for calculating the volume of cylinder. A cylinder has a circular face. And recall, we have treated area of circles. The formula for calculating area of circle is what? Pi r square. So this implies that the volume of cylinder is given as the area of the face, which is the area of the circular face, times height. Area of the circle is pi r square. So putting the two together, we have pi r square times height. Remember, the pi r square stands for the area of the face, then times the perpendicular height, or times the height. Okay? Now, let's just have a tabular representation of the volume of some of the common prisms that we have. Now, square. Looking at square, the face of a square is, cube. I beg your pardon? Cube. Looking at cube, the face of a cube is a square. And what is the area of a square? That is length times length. Then the volume of a square will now be the area of the face times height or length. So, and that is why we have length times length, then times length. For cuboid, the face of a cuboid is rectangular. So, and the area of a rectangle is length times breadth. So, the volume will now be what? The area of the rectangle times length or height. And that is why we have length times breadth times height. For cylinder, the area of the face is pi r square. And so looking at that, the volume will give us pi r square h. Please, I beg your pardon, that is not showing clearly on the screen. Where you have r square is supposed to be pi r square for the area of the cylinder. Then the volume is pi r squared times h. Then lastly, for triangular prism, the area of triangle is half times base times height, while the volume will now be given as half times base times height, then times length, because the half times base times height is the area of the triangular face, then times length. Oh, I believe with this short explanation, we should have a better understanding of what we ought to have had a better understanding of what volume is, and we should be able to calculate the volume of prisms with the general formula. In the next class, we'll be going in details into some calculations based on what we have studied today. Thanks for your time. I remain your tutor, Alabi Oluwadamilare. Goodbye.